We call this an abstract questions. Okay, next one. Number 7. When x is divided by 8, the remainder is 3. Okay? So, this is again abstract because there's like something x there and then we don't know what x there. Anyway, and then what is the remainder when 4 times x is divided by 8? Okay, another one. So, I would be going to represent this one with a clearer value of x so we could see the clear picture of the problem. Okay, so we cannot say, because we cannot see the real answer here. I mean the clear picture of the problem because we don't know what x is. But it says here x, when x is divided by 8, the remainder is 3. So what are the numbers that if you're going to divide by 8, the remainder will always be 3? Okay, so of course we have there 3 first, right? 3 divided by 8, that's nothing. And the remainder is 3. And 11, right? That's also 1. And then what more? 19, right? So shall I say I'll go for 11 so you will be able to see the clear picture of it. Okay, so 11 divided by 8, that is 1 and remainder 3, right? Now, so this is our x, correct? That is our x because it says here x divided by 8, the remainder is always 3. Now, if 4 times x, that means 4 times 11 divided by 8. When 4 times x divided by 8, the remainder is how much? So this one is like 44 divided by 8. So that is 5 remainder 4. So when 4 times x is, what's this? Or 4 times x is divided by 8, the remainder is always 4. Shall we say, let's try 19. If x is 19, that's still remainder 3 if you're going to divide it by 8, right? So 4 times 19 over 8, that is equal to 4 times 19, that is 76. Divided by 8, so that is what? 9 and remainder 4 because 8 times 9, that's 72. 76 minus 72, that is remainder 4. Still, the pattern is the same. Okay? So the remainder is 4. That's letter D. A number 7. The answer for number 7. Let's go for number 8. Let x, y, and z be positive integers such that y is the multiple of x and z. Okay. All of the following statements are true except 4. Okay, so there you go again. This is an abstract question. Gen Ed, pero very abstract, right? Anyway, so x, y, and z positive integers says that y is a multiple of x and z. So shall we say, let's represent, let's say multiple, that is a number that can be divided by, a number that can be divided by, y is a multiple, that means y is a number, a multiple of x and z, so that means y is a number that can be divided by both x and z. Okay? So, shall we say, x is, I would say x is 4 and then, what's this? Z is 9. So, y is 36, right? Anyway, so this one can be divided by 36 divided by 4, that's 9. And then 36 divided by 9, that is also 4. So, x and z can divide y, which is y is a multiple of both x and z. Okay, so let's try to go over the choices in there. Y times z. The dot there represents the multiplication. So y times z, that is, multiply this one, is a multiple of x. Is it a multiple of x? Can we? 9 times z. This can also be actually, but sometimes, wait, let's try another one because this can be true. Anyway, so this is, A here is correct. And then, x is a factor of y. X is a factor of y. That's correct. Letter B. And then, okay, xz is a factor, which of the statements are true except 4? Except 4. Wrong pala, I'm sorry. I'm sorry. The question is like, all of the following statements are true except 4. Except 4. I'm sorry. So letter C there, yeah, that's correct. And letter C, xz, or x times z, that is 36, is a factor of y. X times z is equal to, that's correct. And z divides evenly into y. Z divide evenly into y, that's letter D, is also correct. And x divides evenly into yz. X divided by yz can also divide. Yes, E is also correct. In this case, it's correct. Okay, so shall I say, what more? Let's try. Let's try others. Shall we say this one is like 3, and this one is, shall I say, 7. So y is, shall I say, 42, because 42 can be divided by 3, and also 42 can be divided by 7. So that means 42 is a multiple that that satisfies the condition that y is a multiple of both x and z. Another, let's write the a. A, y times z, where's that? This is z, and this is x. So y times z is a multiple of y times z, that's correct. And letter b, multiple anyway, and letter b, x is a factor of y. X is a factor of y, that's correct. And x times z is a factor of y. So x times z, that's also a factor of y. That's correct. Z divides evenly into y. Z divides evenly, that's correct. Oh my god, there's no... That's correct. And x divides evenly into yz. Yz then, yz, x divides evenly. ERO correct! There's no others like wrong answer in here. This all satisfies the condition. This all satisfies the condition in here. Okay. So there's no answer in here. This satisfies all the conditions. Anyway, let's go. Let's move on. Number 9. When two-digit number is divided by 5, the remainder is 2. Again, this is like this calls about the 8 divided by 3. The remainder is 3 and something like that. That's also the same questions in there. So let's try. Okay. When a two-digit number is remainder is so, which of the following statements must be true about the two-digit number? Okay, so what are the numbers, the two-digit numbers that if you're going to divide it by 5, the remainder is always 2. So what are those numbers? So we have 7, we have 12, right? The remainder is 2. And then 17, 22, and then 27, 32, 37, 42, 47, 52, and 57, 62, and 67. Anyway, and so on. So, two-digit number. The question is like, the sum of the digits is odd. Kung i-add mo yung digits na yan, it results to odd. So, this one is odd, correct? 0 plus 7, 1 plus 3. This is also odd, 1 plus 7. This is even. This is wrong. Okay? So, this is wrong. 1 plus 7 is wrong. So, A does not satisfy the condition. Okay? The question is like, which of the statement must be true? Okay? So, A is wrong. Okay? Next, letter B. So, we have there, the digit in the ones place is odd. Ones place is the first digit from the right. So, ones place is odd. It's also wrong because 2, 2, 2, 2, 2. Right? All 2s. It's some of the digits in the ones place is even, not just odd. Next, the number is prime. The number is prime. It's wrong because this one are composite. This one is composite, composite, composite. So letter C is also wrong. The number is odd. The number is odd. It's also wrong because what's this? 22. Like all ends with O are also even. So letter D is also wrong. And letter E, the digits in the ones place is prime. So remember that all the ones place are just 7 and 2, 7 and 2, 7 and 2, right? Now, 7 and 2 are prime numbers. So letter E is correct. Okay? There you go. Letter E is correct. The ones place only, 7 to 7 to like that. Okay, next one. We have the sum of 3 consecutive integers is 15. So what are those? When I say consecutive integers, that means those integers that precedes each other. Okay? So like shall I say, 1, 2, 3 are consecutive in 3 consecutive integers. Okay? Next, it says here that 3 consecutive integers, the sum is 15. So if you're going to think of any numbers, this one, we're not going to take this problem as an abstract problem. Let's just going to think mentally of like, you know, those numbers that if you're going to add them, it adds 3 numbers that if you're going to add them will result to, what's this? Will result to 15. So if you have like 5 plus 5 plus 5, they're not consecutive, but they're equal to 15, right? So that means this one, you minus 1 here, this one becomes 4, and you add that one here, so 6. 4 plus 5 plus 6, right? This is 15. So they are consecutive. 4, 5, and 6 are 4, 5, and 6 are consecutive integers also, right? So as you can see here, this thing. Now it says here that how many distinct prime factors? Again, distinct prime factors. That's the product of these three numbers have. So like 4 times 5 times 6. This one is what? How many do we have there? 2 squared, right? And then 5 times 6. How many distinct factors do we have? We have only 3. Okay? So the answer there is letter B. Okay? There you go. Next one. If A, B, and C are all integers greater than 1, and A, B, okay, remember that A, B, C are integers greater than 1, and A times B is equal to 21. So A times B is equal to 21, and then B times C is equal to 39. Remember, this one, what's this? B are the common. So we have like 21 is what? 7 times 3. And then this one, 3 times 13, right? Look at that. B are common, so that means 3 are also common, so that means B is equal to 3, right? So A is equal to 7, right? And then C is equal to 13, correct? That's it. Now, the question there is like, which of the following choices give the correct ordering of the numbers? So C is greater, so we have there, and then A, and then B. So B, A, C. It's letter A. Okay? There you go. It's letter A. Next one, we have, nakikita niyo ba ako? Anyway, number 12. How many positive integers less than 20 have odd numbers and distinct factors? Okay, so what are the numbers? What are the numbers that have like odd distinct factors? Okay, distinct factors. So, shall we say 15 is a number less than 20, right? So how many factors do we have there? 5 and 3, and then 15 and 1. So how many factors do we have? 1, 2, 3, 4. There are 4, right? So 4 is not odd. It's an even. Okay? So the question there is like even. Odd, I'm sorry. So we can have, what are those number anyway? What are those number? So we can only have like less than 20. We have 1. We have 4. We have, what's this? 9. It's like 1 squared, right? Distinct. There's only 1. It says here distinct factors. We have 1. Kasi may repetition ng this one is just 1 or 1 squared. This one is like 2 squared, and then what more? We have 4 and 1, right? How many distinct factors do we have? 3, correct? Next one, we have 3 squared, and what more? 9 and 1, right? So we have 3 again. 1, 3, 3 are all odd, what's this? Distinct factors. Remember that. And we have there, 16 is like 4 squared, and then 8 and 2, and then what more? What more? We have 16 and 1, right? So we have there how many? 5. Okay, so this one is 5, this one is 3, which is like being asked in the problem. This is like how many odd distinct factors or prime factors there. Okay? So there you go. Next one. In the repeating decimal, 0.714